Okay. So this is Mizna from University of Naples, Parthenope. I am a PhD student in my final year, and I'm going to present my work done with the collaboration of my two professors, Professor Antonella and Professor Fabio Di Felice, on the topic of hybrid decision support framework for sustainable business optimization. Let me just give you a quick view of what we will cover today. We will start by discussing the overarching goals of and methods of our research, and then we will dive into the challenges that motivated us to conduct this research. We will discuss on the tools and methods that we have implemented, and finally we will conclude with the findings of this research along with limitations and recommendations for future work. This research is basically a four-step approach to address sustainability in decision making. We started by observing and prioritizing sustainability criteria using AHP. That also helped us to align our actions with industrial benchmarks and their objectives. And then we integrated qualitative prioritization along with the quantitative impact assessment that enabled us to get actionable and data-driven decisions. And then we validated our model with the manufacturing industry to optimize strategy and to achieve sustainability goals. Not only this, but we also observed that the integration of both EHP and regression is not sufficient enough to get large data sets working efficiently. So we implemented then in canine for scalable analysis. Coming to the background of my research, the question arises that why sustainability is crucial in decision making. The industries are facing increasing pressure to balance economic growth with environmental and social responsibility. So there is a need to change to circular economy practices and introduce resource optimization and to comply with the strict regulatory standards. Sustainability focused decision making allow us to address these sustainability challenges. Uh, um, and they can then align with the global benchmarks like European Green Deal. Now, where is the gap? Most existing tools lack predictive capabilities and they do not have sufficient methods to cover all these three dimensions. This is where our research bridges this gap by not only providing the qualitative prioritization, but also giving quantitative impact assessment. This is where we are selecting our sustainability criteria using AHP. Now coming to the regression analysis. Regression analysis is done to get the impact, to quantify the impact of our sustainability criteria, just to ensure that the decisions we are getting or the outcomes we are getting from sustainability criteria are not only subjective, but also backed up by data-driven insights, and that help us to get the confidence in the outcomes we are getting. Like, for example, we can predict that by adopting eco-friendly practices, how it can reduce the cost and improve compliance. Then we ensured that all the data and impact assessment that we are getting is scalable and reproducible, for which we introduced Canine. In context of sustainability, if we talk, Canine basically handles complex and large multi-criteria data sets efficiently. And it provides a framework that's scalable and for broader applications, not only for a specific one. Also, it provides transparent and modular workflow so that stakeholders can address this sustainability issue and validate then and adopt the framework according to their specific needs. So the proposed work approach works in a closed loop, so we can handle all unfolding circumstances like mentioned here, with unfolding interaction with different stakeholders, and it's a continuous in collaboration work with different stakeholders. Coming to the research problem. Global industry contributes 24% of greenhouse gas emission. This is where the resource efficiency has become a critical factor. As I said, that European Green Deal is pushing businesses to adopt circular economy principles, but 60% of the businesses are struggling with this alignment. Also, the challenges like sustainability and profitability together is challenging due to cost efficiency trade-offs, and existing AHP lack predictive capabilities, and scalability remains an issue for large data sets. Talking about in context of European market, as I said, European Green Deal is pushing businesses to adopt circular economy, and they are committed to invest 1 trillion euro by 2030 to reduce landfill by 50%. To achieve this kind of ambitious goals and industry needs, we need innovative tools and framework. Um, this is where our framework gives a good example to integrate technologies like EHP regression and canine. Now, the question arises, there are the three basic growth drivers that drive these sustainability efforts. First of all, resource efficiency demand. 80% of the consumer now demand eco-friendly practices that push businesses to adopt sustainability. Similarly, energy efficient practices cut operational cost by 30%, as given by IEEE report 2022. Regulatory incentives and the demand for transparent supply chain are accelerating this adoption. To address these challenges that we just discussed, we have defined five primary objectives in which we will define our prioritized criteria, and then we quantify their impact on business key performance indicators, and then analyze their effect and for scalability and reproducibility of processes, and to identify their efficiency. Not only this, to analyze the robustness of our proposed model, we conducted sensitivity analysis, and then we deliver our predictive actions on sustainable strategies. Now, the question arises how our proposed systems support decision making. By combining AHP, we are basically evaluating and prioritizing sustainability criteria. How? By gathering inputs from experts to establish credibility of our proposed research, by implementing it in empirical validation to ensure scalability and reliability, and implementing regression and canine to get transparent and aligned decisions that are ready for implementation. Our research design is basically is an integration of expert opinions and structured methods, where input is gathered by literature, ISO 14001 guidelines, and experts' opinion that decided for the sustainability criteria using set a 9-point scale via super decision software. Then we applied a regression analysis on the criterion's impact, sustainability criteria's impact. We quantified the criterias on business KPIs by implementing it and getting data from 50 manufacturing projects, where we have achieved a model fit R square greater than 0.85, representing a strong correlation between criterion weights and outcomes. Just to verify the efficiency and robustness of our proposed analysis, we conducted sensitivity analysis, which proved that resulted in plus minus 10% of weight variations. This is the basic criteria selection to resolve the issue of insufficient sustainability decisions. As we discussed earlier, our proposed research is bridging the gap of covering all three dimensions like environment, social, by covering a skill development, and material method measurements and machine, covering the economic part. This is our proposed AHP model for prioritization, working in three different layer level. One is the goal, the second layer is the criteria, and then we have defined different alternatives. The key findings that we got from our AHP model analysis was environmental impact was with a criterion weight of 45.29% was considered as the top criteria, followed by resource efficiency. And next, the cost profitability and regulatory compliance is of moderate importance, whereas the skill development was less critical. And among the top alternatives for action, circular product design was among the first one, followed by energy optimization and eco-friendly materials. We also identifies the synergies and criteria, like to check the strong alignment between different criteria and which criteria are less prioritized. From there, we observed that environmental impact is closely aligned with eco-friendly materials. That means if we implement this kind of criteria, we get maximum outputs from businesses. But if we switch to skill development, we have observed that we need to invest more and we need regulatory or strategic interventions to close gaps and boost long-term sustainability. The main target is to balance direct impact point A with capacity building point B for getting maximum outputs from businesses. Coming to the next sensitivity analysis for the AHP model that we done to evaluate the robustness of AHP rankings under weight variations, we have observed that when implementing to the environmental impact, we have observed a rank reversal by shifting our weights up till 46%. We have observed that it shifted it priority from eco-friendly materials to circular product design. Similarly, for technological feasibility, we observe two rank reversal. At 54%, it prioritizes energy optimization and circular product design. And then at 59%, we have observed that closed loop chain has become its priority. So it means it demonstrates the adaptability and reliability of this model under varying inputs. This is the graphical representation for priority fluctuations due to weight variations. I'll cut to the short. This is the basic step-by-step approach of this model, where canine workflow is the initial first step, and prioritization and impact assessment quantification is a continuous feedback loop process of this framework. And finally, the decision we get, we are confident in those decisions. Lastly, the canine workflow analysis, we have identified that the top priority criteria attributes effectively is analyzed by using canine workflow. For example, the highest priority was given to closed loop supply chain with the mean value of 0.631. That indicates a strong alignment with the priority factors for sustainability. Whereas energy optimization with a mean value of 0.290 indicates that while it is also important, energy optimization, but maybe not as impactful as compared to the other criterias. Then we have also identified the variability in different priority criterias, prioritization of different criteria. For example, digital integration that is done by assigning it to the stakeholders and then measured it by a standard deviation. Digital integration has the highest standard deviation. That indicates diverse opinions from different stakeholders. We can say that maybe due to the technological maturity levels, each industry may have different response to the digital integration. But on the other hand, closed loop supply chain has the lowest variability. That means everyone has a strong consensus about its importance. Then for this skewness, if we talk about, it's basically, it identifies the biasness in data distribution. Energy optimization being the right skewed means that it has more lower priority scores and a few higher ones. But in case of closed loop supply chain with a value of minus 0.97, we have observed that it has a highest priority scores. Similarly, we have observed sustainability scores ranging from 0.083 to 1 clearly indicates the differentiation of priorities according to the range. Predictive power was of moderate accuracy. We have also found out the errors with the mean absolute, RMSE, and MAP that that are relatively low, but that suggests there is still room for improvement for this framework. Coming to the residual analysis, it basically tell us that where our model under or over predicted our criteria. This is the basic our linear regression model along with the residual analysis and the priority values for sustainability attributes. In a nutshell, we have presented hybrid model that showed that digital integration and closed loop supply chain are the top predictors. Also, the framework aligns with regulatory goals and market trends. The limitations of this research included linear assumptions in regression and the exclusion of qualitative factor, for example, culture, that we didn't consider. In future, we will expand our data sets, incorporate advanced predictive analytics, for example, machine learning and simulation, improve our sensitivity analysis with real-time data, and explore cross-industry application to test the generalizability of our proposed research. Thank you very much for your attention. Any questions are welcome.
Okay. Okay. Are there any questions? Because she's the same, the chair and the presenter are the same person. I'm going to share that. Is there anybody in the room that wants to make questions to Mizna?
Thank you very much. It was excellent presentation and
Excellent, yeah.
excellent work. I think the sustainability assessment using multi-criteria and hybrid thing is the most widely used, I think. So you have done, I think it's one of the very good contribution. That's why
Thank
I
you so
feel,
much.
but I'm not currently up to date with this research. Uh, could you rate your contribution? How the recent sustainability assessment with multi-criteria analysis and your contribution to my judgment, it is at the higher level. But you have done a lot of literatures and studies, and if you have to evaluate on yourself, where do you rate the work what you have done? Thank you very much.
Thank you for your question. That was a really interesting question. I would like to answer it by saying that it's all about the scientific contribution, and scientific contribution, we cannot rate it because everybody is putting their own efforts to do the best at their part. So for me, I have done my best part to contribute to the science in my way, as I have shown that by designing this framework, and then we implemented in 50 different manufacturing industries. We implemented it, and then after getting their results, we came to some conclusion that these are the basic sustainability criteria. And not only this, we also got the opinions from experts from industries, manufacturing industries. Like we contacted sustainability experts, the teams of LCA from different manufacturing industries, specifically textile industry, then the plant managers. So in my opinion, this is the basic requirement if we would like to validate it somehow. This is the basic requirement to validate it at some point, and that we have done. So I cannot specifically in a number scale my contribution because it's a continuous process. But I have done my full efforts to contribute in science at
Excellent.
any
Excellent.
point.
That's
Thank you.
the one best out of you. I think it should be good contribution. Thank you very much and best wishes
Thank you.
for the
Thank you
Thank
so
you,
better.
much. Thank you
Mizna.
so much.